Welcome to my channel, Simple Ways to Learn Statistics. Myself, Sandesh B, lecturer in statistics. So today we are discussing about the topic theoretical distributions. So frequency distributions are broadly classified under two heads. One is the observed frequency distribution and the theoretical frequency or expected frequency distributions. So observed frequency distributions are based on observation and experimentation. So theoretical distributions are deduced mathematically on the basis of previous experience or theoretical considerations. Theoretical distributions are derived using the theory of probability for the outcomes of a conceptual experiment. So probability distribution of a discrete random variable is known as discrete probability distribution. Probability distribution of a continuous random variable is known as continuous probability distribution. So random variable is discussed in the first PU chapters in the statistics syllabus. First PU chapter, we are already discussed about the random variables. In the random variables, there are two types of random variable. One is the discrete and another one is the continuous. Here, the probability distribution of a discrete random variable is known as discrete probability distribution. In the same type for the continuous random variable is known as continuous probability distribution. In the second PU statistics, we discuss both the discrete as well as the continuous probability distributions. So some of the discrete probability distributions are, one is the Bernoulli distribution, second one is the binomial distribution, third one is the Poisson distribution, fourth one is the hypergeometric distribution. Some of the continuous probability distributions are normal distribution, chi-square distribution, and students t distribution. So today in this video, we are discussing about the concept Bernoulli distribution. The definition of the Bernoulli distribution is, or Bernoulli distribution was discovered by the Swiss mathematician James Bernoulli. So this is a discrete probability distribution. So the definition is, if x is a discrete random variable with probability mass function, probability of x is equal to x, that is equal to p power x q power 1 minus x, where x is equal to 0, 1, p lies between 0 and 1, and q is equal to 1 minus p. Then x is a Bernoulli variate. The distribution of x is called Bernoulli distribution. In this definition, or in the theoretical distributions, we use 2x. That is, one is capital letter X and other one is small letter x. For the random variable, we are using capital letter. For the value of the random variables, we are using small letter. Therefore, here we assign probability of x is equal to small letter x, that is equal to small letter p to the power x, small letter q to the power 1 minus x. X, small letter x can take the value 0, 1. So p, small letter p is the probability of success and small letter q is the probability of failure. Therefore, p plus q is always equal to 1. In that way, probability is always lies between 0 and 1, and q is equal to 1 minus p. Features of Bernoulli distribution. So Bernoulli ಕೆಲವೊಂದು features ಅಂತ ಹೇಳಿದ್ದಾರೆ. So Bernoulli distribution has one constant, namely p, which is the parameter of Bernoulli distribution. So Bernoulli distribution has only one parameter, there is a p. There is also the Bernoulli distribution is also called as the uniparametric distribution. The second one, x can take the value 0, 1 is the range of Bernoulli distribution. So range and only x can take only the two values 0 or 1, not from 0 to 1. Here 0 or 1, only the two discrete values. Third one, for a Bernoulli distribution, probability mass function is P of x is equal to x, that is equal to p power x q power 1 minus x, where x is equal to 0 comma 1, 0 less than p less than 1. That means p lies between 0 and 1. Q is equal to 1 minus p. Here we are particularly denote 0 less than p less than 1. Not less than or equal. Less than or equal and so p lies between 0 and 1 except 0 and 1. For a Bernoulli distribution, mean is equal to p, variance is equal to pq, standard deviation is equal to root pq. In a Bernoulli distribution, mean is greater than variance. So Bernoulli nalli yavaglu kuda mean of the distribution is always greater than variance of the distribution. So these are the 5 features of the Bernoulli distribution. Features and so these 5 features Bernoulli nalli 5 features ide order. So next binomial, Poisson and hypergeometric ಮೂರು distribution ಇದೆ order. ಅಂದ್ರೆ first feature ಯಾವಾಗಲೂ usually ಹೇಳುವಂತದೇನೋ ಒಂದು ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳೋದಕ್ಕೆ ಈಸಿ ಅಂತ ಹೇಳಿದಾಗ first feature, that is the parameter, second one is the range, third one is the PMF, fourth one is the mean variance standard deviation, fifth one is the relation between mean and variance. First 4 ಅಂತೂ 4 distribution ಅಲ್ಲಿ ಹೇಳ್ತೀವಿ, Bernoulli, binomial, Poisson and hypergeometrically. First 4 ಇದೇ ಆರ್ಡರ್ ಅಲ್ಲಿ ಹೇಳ್ತಾ ಹೋಗಿರ್ತೀವಿ, ಯಾಕಂದ್ರೆ ಹೈಪರ್ಜೋಮೆಟ್ರಿಕಲಿ ರಿಲೇಷನ್ ಹೇಳೋದಕ್ಕೆ ಹೋಗಲ್ಲ, ಮೀನ್ ವೇರಿಯನ್ಸ್ ನ ರಿಲೇಷನ್ ಅಲ್ಲಿ ಹೇಳೋದಕ್ಕೆ ಹೋಗಲ್ಲ. ಸೊ ದೀಸ್ ಆರ್ ದ 5 ಫೀಚರ್ಸ್ ಆಫ್ ದ Bernoulli distribution. So for the Bernoulli distribution, consider some problems. Here first problem, if p is equal to 0.25 for a Bernoulli distribution, find mean and variance. Already we discussed about the features of the Bernoulli distribution. In the fourth feature, we said that is the mean of the Bernoulli is p and variance of the Bernoulli is pq. Here they are given p. So p is equal to 0.25. That is given p is equal to 0.25. Then q is equal to 1 minus p. That is q is equal to 1 minus 0.25 is equal to 0.75. Then mean, first mean is equal to p is equal to 0.25. Then variance is equal to p into q. Here we know the value of p, that is 0.25 into q. Already we calculate the value of q. Q is equal to 0.75. Then the multiple value of multiplicative value of 0.25 into 0.75 is equal to 0.1875. This is the mean and variance of the Bernoulli distribution. Consider another problem. Write down the PMF of Bernoulli distribution with parameter 0.7. Also find standard deviation. Here they are asking about the probability mass function of a Bernoulli distribution. Here the probability given values, that is given p is equal to 0.7 because parameter of the Bernoulli is p is equal to 0.7 and q is equal to 1 minus p, that is 1 minus 0.7 is equal to 0.3. So these are the two values p and q. Then they are asked about the PMF, probability mass function. General PMF, that is probability of x is equal to x, that is equal to p to the power x q to the power 1 minus x, x is equal to 0,1 with the range. Then probability of x is equal to x. You know the values of p and q. Here p is equal to 0.7 to the power x, q is 0.3 to the power 1 minus x, x is equal to 0,1. This is the PMF of Bernoulli distribution with parameter 0.7. And they are asking about the standard deviation. So formula for standard deviation is equal to root p into q, that is equal to square root of p is 0.7 into q is 0.3, that is equal to so 0.21. The square root of 0.21 is equal to 0.4583. So this is the standard deviation of the Bernoulli distribution. So consider one more example. If P is equal to 1 by 2 for a Bernoulli distribution, write down the mean and variance. So given P is equal to 1 by 2. Here, this is small letter P. So P is equal to 1 by 2. Then Q is equal to 1 minus P is equal to 1 minus 1 by 2 is equal to 1 by 2. So ಇದನ್ನ ಬೇಕಾದ್ರೆ fraction ಹಾಗೆ ಇಟ್ಕೋಬಹುದು ಇಲ್ಲ decimal convert ಮಾಡಬಹುದು. Here I consider in the fraction only. P is equal to 1 by 2. Q is also equal to 1 by 2. Then mean of the Bernoulli is small letter P, that is 1 by 2. Then variance is equal to P into Q, that is equal to 1 by 2 into 1 by 2 is equal to 1 by 4. So mean is equal to 1 by 2, variance is equal to 1 by 4. Here we can observe the values. Mean is 1 by 2, variance is 1 by 4. So we know that 1 by 2 is greater than 1 by 4. So mean is always greater than variance. So because reason ಅಂತ ಹೇಳಿದಾಗ P and Q lies between 0 and 1. P ಮತ್ತೆ Q ಏನು 0 ಮತ್ತೆ 1 ಮಧ್ಯದಲ್ಲಿ ಇರೋದ್ರಿಂದ so mean is always greater than variance. Next, we consider the result. Here x1, x2, etc., xn are independently and identically distributed Bernoulli variates with common parameter P. Then their sum x is equal to x1 plus x2 plus etc. plus xn is a binomial variate with parameters n and p. Here the sum of the Bernoulli variates are always equal to the binomial variate. So Bernoulli, sum of Bernoulli converges to binomial variate. So this is the result. Then next one is the binomial distribution. So in the next video, I will explain about the binomial distribution. Thank you. In the next video, the concept will be continued.